Hi, Brian.
Okay, I think we can just give people a few more minutes to get back from lunch. Okay, I think we can do some slow start. Welcome to PANRG. Brian with us remote. Appreciate it staying late. Okay, so IETF Note well. Please take a look if you have not seen it many times this week, and even if you did, still take a look. Housekeeping. Please scan this QR code so your name can appear as attendee. If you want to ask a question, I would appreciate if you use on-site tool in Meetecho, but there are not so many people today, but still, it does make chair's life easier if you use the application to join the queue, so I can manage the queue from one place. And if you're participating remotely, please keep your audio video off. Yeah, and I was going to say please wear the mask, but everyone is doing it already. Great. Yeah, oh, completely forgotten. We need minutes taker. Come on. Huh? I think we need to add a like random number generator to randomly select people in the room. Come on, I guess we really need this. Sharesh, really, thank you very much. I'll buy you a drink after. Agenda, I think I got the time wrong, but so ignore the time slot. Time zones are hard for me. So what we have today, I'll be speaking for a few more minutes, and then we're gonna have quite long, interesting discussion about Cyan. Nicola going to talk about it, and Brian and I will keep the room in order. And then we have two presentations, each for 15 minutes. One is overlay routing problem statement, and the second one is separation of data path and data flow sublayer. So any last minute agenda bashing, suggestions, comments, disagreements about what you're going to talk about? Okay, looks like we all good. So what's happened since Vienna? So we had an interim on Cyan architecture. There is a link to materials from the slide deck if you don't know where to find the interim materials. And we passed the research group last call for path properties, but we're currently pending the updated version. So I think even Shepherd write-up has been done. As soon as Rees submits the updated versions, we're probably going to advance the document. And that's all I have. Brian, any comments? Did I miss anything?
Nope. All good. Thank you.
Okay, so then we move to. You going to share the slides? Or you want me to present? Oh. Oh, beautiful. Look. Yeah, I'm granting you. Technology works.
That should be it. All right, I'll get started then.
Yeah, like stay close to the mic, probably.
Yeah.
Yeah.
All right. So, okay, the slides are here. Good. So first of hi, everyone. My name is Nicola from ETH Zurich, and today we will be looking at Cyan, the next generation Internet architecture. Specifically, we'll be looking at a component analysis. So before getting started, I wanted to quickly touch on some background information. We are not going to talk about how Cyan works in details today. We are not going to give an overview. We have already done that before. So if you want to know more about that, please refer to the existing draft that we have been discussing at the interim meeting. The draft is linked in the slide deck. But I'll still give you a very quick overview about what Cyan does and what it is, just in case you have not heard about it before. It is a path-aware internet architecture. It is interdomain. And when designing it, we focused on certain properties. First of all, availability. And availability means not only availability in case a link fails, but especially availability when there are adversaries in some parts of your network. And this is very important when you do build something that has to be deployed interdomain, where there's different domains and they don't necessarily mutually trust each other. Security is also a very important component. Um, I'm talking about routing security, so making sure that traffic cannot be redirected, and ultimately scalability when it comes to being able to deploy Cyan on a large scale were all very important when designing the architecture. So it started as a research project back in 2009, and the architecture somehow slipped out of the lab. So today it is in production use by a few ISPs, mostly in Europe, and specifically in Switzerland. The interbanking network is now being migrated to Cyan. So whenever you pay some money from one bank to the other, then these banks have to send some bits to each other, and this is being migrated to use Cyan. That means that we have gained some deployment experience, and there's also several implementations, which is why why standardization is quite important right now, and that's why we're having this discussion here. So what happened so far? Let me just get to the right slide. Before getting to the discussion, I wanted to just remind of another property of Cyan, and this is the property of isolation domains. So in Cyan, autonomous systems are grouped into isolation domains, and they are the big circles that you see in this drawing here. And each node represents an autonomous system. It is very important to remember this structure because each isolation domain has its own root of trust. And this is independent from other isolation domain. And this property is quite important to understand how the architecture works. This is also important because of scalability, because the routing process is somehow split into an intra-ISD and into an inter-ISD. So just keep this in mind, and we'll get back to this concept later. What happened so far? So we have been discussing Cyan already at the IETF114. We had some discussions at the routing area open meeting. We had a site meeting to brainstorm about possible next steps. And so I wanted to thank the chairs of PANRG for actually giving us, for now, a home where to have discussions about the architecture. So back in June, we actually presented a first overview draft that describes the architecture from a high level. And during that discussion, there were quite a few questions about Cyan. And that's what we're going to try to look into today. So the questions specifically were mostly about Cyan and its components. Cyan is designed as a system, so there's few components that interact among each other. And there were quite a few questions about what each component does and what the dependencies are between those components. There were also questions about what protocols are reused, what protocols are not reused, and eventually why. So today we're going to try to dig into these aspects. We are not going to be looking at the motivation. I think in our last discussion, there were some mentions of a gap analysis draft. And in the end, it seemed to me that it was more important to focus on the components rather than on the gap analysis. So we will not be focusing on the gap analysis today. So I guess we can get started and we can start the discussion about components. By the way, if you have questions, I think we have ample time later. So if you can keep them for the end, and then we can, we will have extensive time for discussing that. So when you want to send traffic on Cyan, well, as an end host, going bottom up, you basically need to have a data plane that is doing packet forwarding. And Cyan is path aware, meaning that Cyan packets actually contain an AS path inside the packet header. And the data plane is taking care of, getting this path and then doing the actual forwarding. That means that the data plane has a dependency on something that has to provide these network paths. And since Cyan is focused on security, we want this network path to actually be authenticated. And that's why we have a control plane in Cyan that is taking care of figuring out, basically discovering routing information and disseminating it to the data plane. In order to authenticate this network path, it is important to have some cryptography that can basically do this authentication. And this is why the control plane is actually relying on the Cyan control plane PKI to basically get certificates and authenticate this information. And Cyan has its own PKI exactly because this authentication process is based on the trust model that is provided by isolation domains, the big circle here in the drawing. So let's start looking at the first component in more details. Let's go from top to bottom and let's look at the control plane. When it comes to the control plane, we mentioned how flexible trust is a very important property of Cyan. So we want each isolation domains to have its own roots of trust. And this is what we call trust root configuration, or TRC, that you see in the drawing. Each ISD has its own roots of trust, and it is independent from other ISDs. And this allows end hosts in Cyan to flexibly decide who they want to trust and who they don't want to trust. So this feature, for example, is quite used in the banking network, where basically banks can have communication among a subset of trusted parties. And another very important property that we wanted to have in Cyan is to have to make sure that in case an entity is compromised, then the security of the whole isolation domain cannot be compromised. And this is why within the isolation domains, there is actually a voting mechanism in the PKI, so that very important changes to the trust and to the certificates have to be carried out only if there is consensus. And this not only prevents that a single compromised entity can somehow take over the whole isolation domains, it also makes sure that governance is somehow multilateral. And this is also something that we see works pretty well in the finance network. So when it comes to inputs and outputs, when we look at this component, well, the PKI is quite independent. So there is only a minimal need of some initial bootstrapping information. So autonomous systems have to initially, let's say, have a ceremony to prepare their initial certificates. There needs to be time synchronization between autonomous systems so that certificates can be verified. And besides that, there's not really other strong dependencies when it comes to the PKI. And what the PKI does to the whole architecture is that in the end, it provides this trust policy expressed as a TRC And then it also provides each Cyan autonomous systems with a certificate, an AES certificate that then is used for routing. So moving on to the next component, the control plane is the one that is actually doing the routing. And if you think about it in terms of input-outputs, well, the idea is that the control plane starts from an unexplored topology. It doesn't know anything about paths. And the goal is that we want the control plane to be able to figure out network paths. So we want the topology to be explored, and we want this to be done securely. So we want each, let's say, a path segment to be actually authenticated. And that's why this component takes basically the certificates from the PKI also as an input, and it relies on them for authenticating path information. So the control plane basically does this process that we call path exploration, and in detail it is called beaconing. So that's how it explores the topology. Once this topology is explored, these path segments are actually made available by the control plane to end host. So another function is to disseminate this routing information from the control plane within an autonomous system to end hosts that actually want to communicate. There is authentication. That means not only on path segments, but also on control messages, so that basically a Cyan host receiving a certain message can be sure that this was created by the entity that claimed to have created that piece of control message. In addition to this, Cyan is multipath, and that means that the control plane has to be able to provide multiple paths to end hosts. And we want this to happen also somehow scalably, which is why we use this concept of isolation domains to split the routing process into an inter-ISD and intra-ISD. And these two-tier hierarchy somehow helps with the scalability. So as an output of the control plane, we basically get these authenticated path segments. And these are really hop by hop, so per AS and interface. And this is what in the end is made available to the data plane. The data plane is the one that is doing the actual forwarding in Cyan. So it takes these path segments from the control plane. It also relies on these authenticated control messages. And what the data plane does in the end is to really create packets with a full path inscribed in the header. You can see this in this little drawing here. And this is what is actually used by Cyan routers then to do the forwarding. As an input, you can think of application requirements as being part of what is demanded to the control plane. So if you have an application that is latency sensitive, for example, you can ask the Cyan control plane, give me a latency optimized path. And the data plane will basically select a path that can give you this property. The fact that path is actually inscribed in packet headers is very interesting. First of all, because routers then become very simple. They don't have forwarding tables, so there is not really need for dedicated hardware. Path segments are authenticated at each hop in routers, and this is actually happening with a very simple AES operation. So it is something that can be offloaded by any CPU, which also makes Cyan routers very easy to deploy on any, let's say, commodity hardware. So in our implementations, I think we can run up to like some 100 gigs on a, let's say, commodity server. And besides that, one property of the data plane that was really part of the design is that Cyan is only in interdomain. So it only functions when packets go from one AS to the other. When it comes to inside an autonomous system, Cyan by design reuses what is existing. So that means that the existing both routing protocol and the existing forwarding plane can be reused. So that could be, let's say, an MPLS or an IGP or segment routing. And so in the end, the data plane is what is providing this inter-domain multipath communication. Multipath is also interesting for availability because end hosts have the ability to switch path in case something breaks. And this is also important to keep in mind that path selection in Cyan is really pushed to end hosts, which helps keeping the network and routers relatively simple. Another design property to keep in mind is that Cyan splits basically locator and identifier when it comes to routing. So routing happens based on these ISD and AS tuples, and end hosts can be addressed with existing addressing schemes. So existing deployments, they use IPv6 or IPv4. So I think that's it when it comes to the components in detail. So to summarize, we described how Cyan relies on three fundamental core components for the architecture to function. We have seen how the PKI only requires some initial bootstrapping information, and then it basically provides certificates and trust policies to the control plane. The control plane is the one responsible for doing the actual routing, which is basically discovering the topology and then making this routing information available to the data plane. The data plane in the end is the one constructing end-to-end path and doing the actual forwarding, which in the end gives you this inter-domain multipath communication. So just a sec. So before wrapping up, I wanted to briefly mention how Cyan interacts with existing protocols. When it comes to the control plane PKI, we mentioned before the trust model. Cyan has these isolation domains, and each one of them has its own roots of trust. And this makes it somehow difficult to reuse existing PKIs, for example, the web PKI, where all the root CAs are idempotent. And this is very different in Cyan, and I think this is something that basically motivates our approach and adds this concept of multilateral governance. On the implementation level, well, the PKI reuses X509 certificates, but of course, then on top of it, you have all this voting mechanism to, let's say, find consensus among the autonomous systems administering an ISD and so on. So that's what makes the control plane PKI a bit unique. On the control and data plane, we mentioned before that Cyan reuses intra-domain whatever is existing, so both in terms of routing and in terms of forwarding, and this was by design. Another, let's say, topic that is somehow close to Cyan is Rpki, and people might think, okay, they're trying to do the same thing, but Cyan does provide you authenticated path information, but keep in mind, I mentioned that end host addressing is not really part of the core Cyan. So that means that Cyan does not really have prefixes, and there is not really prefix, let's say, origin authentication in Cyan. Which is why, if you look at Cyan transition mechanisms that are not part of this draft and this discussion, but we do have some proposed transition mechanisms from, let's say, IP to Cyan, and all those mechanisms, they do actually build on top of Rpki in order to do basically prefix origin attestation. So I think the two technologies are somehow potentially complementary. One reason for Cyan having its own control plane is that messages are all authenticated. And this is something that I think we don't see in many protocols. So we think this is something novel that Cyan could also contribute. And yeah, when it comes to the data plane, and host addresses are reused. So there is not really need to change that. There are some gateways that are needed in case you have, let's say, coexistence between Cyan and the existing word. But we believe that in the end, the amount of change needed to introduce Cyan is reasonable, or at least you don't have to rip off all of your network in some way. I would like to summarize. Basically, we discussed how Cyan has three main components. This is really the bare minimum that you need to deploy Cyan in your network: data plane, control plane, and PKI. We have seen how the PKI is the more, let's say, independent one, in the sense that it does not really rely on any other components. But then we have also seen how the data plane and control plane, they, let's say, hierarchically rely on each other in order to provide certain properties. So I think now we have quite some time for a discussion. first of all, there is our draft, and keep in mind this is really a 0-0, so it's something we try to put together rather quickly. So we welcome your feedback on the draft. We actually already got some feedback, so I wanted to thank the people that have been reviewing that. I hope this helped to clarify what Cyan core components are and how they depend on each other. I think we can go more into the details in some directions if you have specific questions. I think the goal would be to pave the road for future work on Cyan, could be within the ERTF, EITF. So we first of all want to advance the 2 existing drafts and hopefully make them of better quality. But we also want to get started at some point with the initial Cyan specification. So the idea is really to document what exists already, what is deployed today. And we believe that doing that might also be a very good way to first lay down what we have today and then pave the road for later on eventually standardization. So having more work and getting to work together on this. And this could be done here or, well, we don't know yet. So thank you for your time, and yeah, I'm looking forward to the discussion.
So Nicola, thank you very much. Applause. I had one quick question with my RG chair hat on first, and then we'll get people time to get into the queues to ask questions. I saw a couple in the Jabber room or the Zulip room that I'd like to see, come up to the microphone. So you said you'd like to see, or you'd like to advance the 2 existing drafts. Are you talking about publishing those as RG drafts within PANRG, or just getting them, like, improving their state? Right. So, for example, I read the decomposition draft. I think that this presentation was a way better presentation of the decomposition than the decomposition draft was. So there's which is, when we came into the interim, that's what we said to prioritize. So well done. But are you looking to publish those as RG drafts?
Well, first of all, yes, we had 2 more weeks to do some thinking.
Yes.
This kind of exercise, I think it was very helpful also for us to do some thinking on components, and we definitely had more time for the presentation. So these extra 2 weeks, we did a lot of brainstorming. So we'll definitely try to improve that draft. The composition.
Please take that as a compliment on the presentation, not a complaint about the draft.
Yeah, absolutely. But yeah, we got some better ideas later on, let's say, after the draft submission deadline was closed. When it comes to improving that, so ideally, it would be great if we could document the existing. It could be within the research group. I think what we are looking for now is just to get some feedback from the community. So definitely interaction with the research group would be, I think, positive for now. I'm not sure if we could get some of the drafts to be, let's say, an informational RFC or something like that. But I think this would be clear over time.
Thank you very much. With that, the queue is open for questions and discussion. I'm going to call out Eric Klein because he had some very good questions. But Alvaro, come on up first.
Yeah. Hi, Alvaro Retana, FutureWay Technologies. So I understand there are 3 components. How independent are they? Can I have the control plane but use a different PKI or authentication mechanism? Once I resolve the routes in the control plane, can I use a different data plane? Or do we need the 3 components? And I know that the 3 components make up Cyan, but if we needed to develop them or standardize them or implement them or whatever independently, what are the dependencies? Can we, if we finish the control plane work, for example, but we don't have the PKI work, does that mean we can't do anything? Or I'm just trying to figure out if there are alternatives or flexibility with the dependencies.
Yeah. So having the whole system or components working together, I think, helps you to achieve most of the properties. I think you could use some of the components independently, but you would lose some of the properties. So I think I have some backup slides at the end about this. Okay, yeah. So it was kind of, all right. So I think it really depends on components. So for example, the PKI. I think the PKI is the one that is a bit on the easier side because it does not really have external dependencies. And all that it does is that it provides you this per ISD trust model where you have your own roots of trust, you have the voting, you have the way to update certificates over time. And so this is used by the control plane, but it could be used by other things. So for example, we have a Cyan extension that basically derives symmetric keys between any two autonomous systems in the architecture. And these symmetric keys could be used for anything. They could be used for encryption, for authenticating certain messages. So there is actually also a draft about that by my colleague Juan, who is actually, I think, also here in the call. And so I think this could serve some kind of purpose, even if you have it by itself. When it comes to the other components, so I'm thinking, for example, the control plane. Well, the way it works is that it relies on this concept of isolation domains. For example, for scalability, because the routing process is somehow segmented into this intra and inter ISD, so it does need something that mirrors this concept of isolation domains. But you could say, okay, I deploy a Cyan network as a giant single isolation domain. I think you might bump into some scalability issues, and you might bump into some governance issues, because maybe instead of having this voting process that you have in the PKI, maybe you will have a single certificate authority that in the end is in charge of administering the whole the keys for the whole network. So I think this could somehow work, but I think it would lose some of the properties on the control plane. But it does not exclude that somehow things could work by themselves. But I think there would be more open questions about how to do this effectively. When it comes to the data plane, so what the data plane needs in Cyan is basically this authenticated path segment. And here, one of the key things about Cyan is that you authenticate those path segments with all this control plane and this PKI and trust model and so on. So if you were to deploy Cyan network without the control or plane or PKI, I think if you have something that can authenticate this path segment, I think you could somehow make it work, but you would also lose some of the properties there. So maybe you might end up with something just like maybe interdomain segment routing with authentication on top of path segments, which could still be in some way a contribution, because I'm not an expert in segment routing, but my understanding is that there is not really authentication so far, and segment routing, for example, is meant to be deployed in a control environment inside a domain, a trusted domain. So that could maybe help in some way, but it would open more questions. So I think overall the answer to your question is we could have some components working somehow independently. They could give some benefit, but it would be more limited than having all three of them somehow working together.
Eric Klein. Since Brian called me out, Brian, do you want to jump ahead of me here, or are you fine behind me?
Yeah, no, go ahead. I just had Nicola said something and it raised another question, so I'll bring that up later. Go ahead.
Okay. I'll just run through some of the questions that I was asking in the chat that Juan was kindly providing some answers to, and maybe you have some other. I think the first thing I asked was, are existing deployments amenable to any changes that standardization might lead to? If there's something backward incompatible, is there going to be a bunch of people who are actually kind of like complaining that no, we can't change anything?
That is a very good question. I'm personally not, let's say, in charge of those deployments, so I don't think I can answer that. But since we have some deployment, I think a key step towards standardization would be to first document what we have existing and what is somehow deployed today. and then take it as a base for doing some more longer-term standardization work. Whether they would be willing to change, yeah, as I mentioned, this is not something that I could say or commit, because there is, I mean, there's ISPs, there is the banking ecosystem. What I've heard from the past is that if you compare Cyan today to the, let's say, very researchy Cyan that we had a few years ago, already several things actually changed a bit, even in let's say in parts of the header. And this is because with some deployment experience, people realized that some things that were initially designed, they could be optimized. So I think, for example, some header fields were swapped in position to make it a bit more efficient to parse them on routers and so on. So I think there is a margin, but I'm not in control of those networks. And
oh, sure, of course.
This would be
Juan's reply was that the ISPs, many of them have been asking about a possible standard, and it seems that there's reasonable belief that they would be happy to use a standard process. That's what he said.
Yeah.
I also asked if there was a life of a packet or even like a life of a socket kind of summary. He pointed at some documentation and described some stuff in the chat, including like an initial phase of like getting the client actually gets all the paths itself and then chooses paths it wants to use. How long does that usually take? Can that be how much like pre-computation or pre-caching can be done?
Yeah,
there?
that's a good question. So I believe we do have a life of a packet. So there is a book that we have been working on in the past years. I think that is called The Complete Guide to Cyan. And in there is a description of, let's say, a life of a packet, if I'm not mistaken.
Mm-hmm.
There is also one that we also have an older book from a few years ago that also has this chapter. But as I mentioned, a few things changed. So I would recommend to, I would point you to the latest version. When it comes to fetching paths, well, so there has to be an initial path lookup from end host to get these path segments. These path segments have a certain lifetime, so they can actually be cached at different layers. So the way it works, I'm not going to compare it directly to DNS, but you can think about it in terms of something similar to DNS lookup.
Sure.
So there is some initial extra latency of some milliseconds, but it really depends on where you want to go and whether the path server you're actually asking for paths already has this path information. Because, for example, if you want to go from one ISC to another one, there has to be like I'll say recursive. It is not exactly recursive, but there has to be a bit more lookups. But once the core has all those path segments, the next lookups, they will not incur the same latency. So the answer is it depends, but think about it as a DNS-ish way.
There was some other stuff I asked about also about the if the path list is in every packet, how big is the header? And I think Juan said there's like an extra 80 bytes over IPv4 header size.
Yes.
Which implies that there's a maximum path length.
Maximum path length, I'm pretty sure there is one, but I'm not recalling that. I'm not sure. There's some colleagues that are in here. I'm not sure if they remember that. What I know is that usually with each path, then you also get a path MTU that, of course, depends on the links that you have along the path and on the path header, because, of course, the header length is variable. And sorry, what was your other question?
The question was how long, like, what is the max path length? And what happens to networks that are outside of the max path length?
I would have to get back to you. I'm not sure if somebody else in... there are some colleagues that are remote, and I'm not sure if they know about that, but the path is usually an AS path. So Cyan paths are per AS. So for each AS, you have incoming interface, outgoing interface, and AS. So it is usually not something that you would expect to be more than, I'm not sure, a certain number of autonomous systems.
Okay. Yeah, I clearly need to learn more, but thank you.
But yeah. I think Brian is in the queue, or?
Yeah, let me click the buttons. So I was looking at sort of like these slides here, the can we use X alone? Can we use like Y alone? Can we use Z alone? I think that's one good way to look at these questions. The other way to flip it around would be to say, hey, can we take for any of these components, can we replace them with something that is already in sort of like the IETF internet ecosystem or something very much like it, right? Like, so, for example, I think you make a pretty good case that the data plane on its own is probably the least useful thing, and the PKI on its own is the most useful thing. But like, what would it look like to, for example, take the Cyan PKI, some representation of the Cyan control plane, like so that the path beaconing mechanism, right? Like, so I assume you bring that to the IETF, and the first thing we're going to do is change the endianness of it, right? Because it's like, you know, control, change control lives with the IETF, and it's what we did to Quick on the first day. But then like use some existing piece of the IETF ecosystem for the data plane, right? Because I think you made a pretty good case here. The data plane on its own is the least interesting thing. It's like, could we use, yeah, it looks a little bit like Lisp. It looks a little bit like segment routing. Could we use like the SR headers for the interdomain data plane, but then like connect the control plane into, like, you use the control plane to disseminate the path information that then shows up in the segment routing headers, for example.
Yeah.
Right? Like, that's just that's the easiest way I could think to sort of like say, well, we're not going to boil the ocean at first, and we're going to reuse something that exists and is implemented and standardized in the IETF. But there are other, you know, there might be other ways that you could replace the data plane. Did Juan want to come in and answer that question, or did he have a different question?
I have a different question. Thank you.
Okay, cool.
Oh, okay. So going back to your question, whether we could use an existing protocol, well, I'll just start with saying that I'm not a segment routing or Lisp expert. So we have been looking at how they work. But I think investigating how actually feasible this is would require a bit of further analysis. So I think I have a slide about just comparing the protocols, but my tool is stuck. Well, just give me a second, and I think we will. So yeah, we were mentioning, for example, Lisp. So when it comes to Cyan versus Lisp, I think the idea of separating routing identifiers and locators is somehow common. And when you look at transition mechanisms that we did not really get into that much, I think there are some similarities in the sense that Lisp and Cyan both have, let's say, a edge point that acts as a bridge between the Lisp part or the Cyan part and the regular end host IP part. So in Cyan, this is called SIG, Cyan2ip Gateway. And in Lisp, well, I don't remember how this is called, but I think it is like a Lisp router or something that does this kind of encapsulation. So I think there are definitely similar problems that probably where we can probably find some synergies when it comes to this concept. But Lisp is only doing having this let's say two-tiered routing. And there is not much about multipath. There is not much about authentication. So I think the core focus of each one of the two protocols is very different. But yeah, I'm not sure how much they could be potentially integrated. But I definitely think ideas, maybe there could be some cross-pollination of ideas between the two, especially when we look at transition mechanisms, which I think is a discussion that we will have to have. We just did not have it yet here, because we are trying to now look at the, let's say, bare minimum core components. When it comes to segment routing, well, as I mentioned, I'm no expert there, but the idea is that segment routing is intradomain and Cyan is interdomain. So I think they could potentially cooperate in some way where you use segment routing inside an autonomous system and Cyan inter-AS. Let's see if the tool starts working again. Sorry about that. And okay, yeah. But besides that, I think the key difference is really about trust and the trust model. Segment routing does not really have much about working between untrusted entities. So when it comes to your question, could we use one with the other? I think there could be some synergies, but we would have to do more thinking about it, of how this could in practice work when it comes to the details. But definitely there could be potentially some little overlaps, but usually the scope is very different because of the trust model, because of what the protocols do, and so on.
So I know a lot less about segment routing than I should, to be honest. But like this slide is super interesting to me because we have a bunch of properties that we want over on the left side that are missing from the right side. And it's like, okay, the paths are authenticated, but that path authentication is basically coming from the control plane. And then there's sort of like some encapsulation stuff, which, you know, the internet has made a tumble, so I don't really care, you know, how many different layers of headers you have to put on a thing in order to make it work. But like, it seems to me there might be some way to take this path authentication and the ability to run in an untrusted domain from the control plane and integrate it into something that looks like segment routing. For like the packets look like SR packets and can be handled by devices that can do segment routing. But you like, I want to figure out if there's a way to take things from the left column of this slide and wedge them into the right column of this slide. Does that make any sense? Right? Like if you get the path authentication, if you get sort of like the ability to do untrusted deployments from the control plane, could you dip segment routing in that somehow and then get the best of both worlds? Like, this is an inchoate idea. I think we should probably take that offline or to the list, but I like this slide, just sort of like gave me an idea there.
Yes, this is one of the slides that we added after submitting the draft, and yeah, but it definitely needs some more brainstorming. So I would be happy to continue a discussion about this on the list.
Excellent. I will stop hogging the queue then. Thank you very much.
Juan, are you in the queue?
Thanks, Jen. Hi, everyone. Just wanted to go back to the question that Eric had about how happy would be the stakeholders at this moment to participate or even to welcome a standard about like any of these three components for Cyan as a whole. So, I mean, as more and more entities are joining the Cyan network, they are using money and resources to participate, and it is for them quite dangerous to just have one like single entity managing everything. So for them, it's quite critical to actually have a standardization process that everyone agrees upon, and that multiple partners can build routers and can build all that knowledge as well. So that was just to build up on that. Thank you.
Yeah, could have been. So indeed, thank you for this presentation. This is a really nice setup and helps a lot to understand the different components and how everything fits together. And it did help me to understand what's needed much better. And I think it has become clear to you maybe in the meantime, based on all the question discussion, that we won't be able to take like everything together and do everything at once. So we have to go step by step. So I found most useful that you had on all these slides, you had this box called functions and properties. Or actually, I didn't find it useful that it's called function and properties, but because like these are two different things. But the function is the most interesting part that we can standardize here, right? And so can you maybe go back to slide number 8?
Give me a second, it is a bit, okay.
Yeah, so I think here the first two things are actually functions and the rest are properties.
Yes.
So the properties are more requirement for a protocol, but the functions are something that we want a protocol for. And maybe this is actually a very good starting point here, because, and now you can correct me if I'm wrong, because I'm really not a routing expert at all. But path exploration and dissemination is something that we don't really have a protocol for, and that could also be useful for a lot of other use cases and protocols. So maybe that's the first step we can talk a little bit more about in detail.
Yeah, absolutely. So first, thank you for the feedback. I'm happy that this helped. As I mentioned, this was also an exercise for ourselves. So there was a lot of thinking in the background to try to get this. But I think definitely also echoing what Brian was mentioning, I think both the PKI and the control plane are probably the more interesting components that I think could also bring some value around. So thank you for your input. I think we can
And
think about
it's
that.
understand to me that even those two functions here are not completely independent of the PKI, right? So like, even if we start here, there's something we need to think about the PKI. So, but like, yeah, we need a starting point. That's the point.
Yes. Yeah, and I think concretely the starting point could be either the PKI or the control plane, or roughly. Yeah, I think there's already some. Well, I would not say consensus, but some ideas that the data plane maybe is less important for now. So thank you for your input.
Kenneth?
Hi, thanks, Ken Calvert, University of Kentucky. I just want to say, and I don't know as much about segment routing as I should either, but I could swear that I saw something somewhere about extending segment routing to the interdomain area. And I don't remember if it was a draft or something submitted to a conference or what, but I would just observe that I think if you think about that happening, it's hard for me to see how you would avoid ending up with something that's the equivalent of Cyan's ISD isolation domain in terms of the trust structure.
Yeah, I guess Alvaro has an answer.
Right. So there's all kinds of names for domains, right? So in the segment routing architecture, it talks about a segment routing domain. A segment routing domain can be one that has multiple ASs. So traditionally, we talk about multiple ASs and we say interdomain, right? But there are networks that have, operators that have multiple ASs. And so their segment routing domain can go across AS boundaries. So yes, segment routing can work across ASs. If we think about the isolation domain, that's similar to one operator or one administrative domain with multiple ASs inside. So yeah, that is possible to go across domain boundaries.
But I have a follow-up question about that. Are these ASs assumed to be under the same administrative entity?
Because it is correct. That's what I said. Yeah.
Because
correct.
the thing is, in Cyan, within an ISD, autonomous systems are, or at least the design is thought in a way that autonomous systems are under, they are basically different administrative domains, which is also why you have the voting process in the PKI, because, well, we assume that there is some shared level of trust. So ASs could be in the same jurisdiction or in the same industry, but they are not necessarily absolutely the same administrative domain. So I think the thread model behind it, then it would be a bit different from the one that you have in segment routing, if you assume that all the ASs are part of just like a gigantic large network.
It's different. I was just saying that, yes,
Okay.
you can go across domains.
Okay, thank you.
Mirya, are you still in the queue? Okay, I'll remove you. Well, I do not see you on the queue, so I put myself in the queue to ask very, very stupid question. So I assume this requires either changes on the host or some kind of proxy sitting there, right?
Yes.
So basically, how does it work for a host which might want to talk to some Cyan destinations or internet destinations? How does it practically would work on a host?
Yes, thank you for the question. I'll just look here so people can hear me. So yes, this is correct. So there's roughly two ways to communicate Cyan. I think there is a slide about deployment. I purposely did not want to talk about this because we have several transition mechanisms, several proposed transition mechanisms, and I think all of them would require their own discussion because it's quite big. But in a nutshell, you basically either have a native Cyan host that basically has currently a piece of software that supports doing this path lookup and so on, and can talk to other Cyan hosts, or you have a gateway in the network. So this is what we call a Cyan2ip Gateway, and this is what is used in deployments today. So then there is a boundary between the Cyan domain and the end host. And of course, all the path policies and so on, they're all configured on this edge device called the Cyan2ip Gateway. So, yeah, there was a slide about it roughly. So yeah, there is a little slide about it. There is this basically purple device. And in existing deployments, either it is basically deployed on somewhere close to the CPE at the customer side, where traffic is encapsulated, decapsulated, or some ISPs in Switzerland, they started offering like a what we call a carrier grade Cyan2ip gateway, where they run this inside their core network. And when you want to go to some destinations that are behind Cyan, then traffic ends up on this gateway, and then it continues over Cyan. Besides that, there is some proposed transition mechanisms that, let's say, aim at coordinating these gateways on a large scale, but that's a whole different discussion.
Thank you. So I don't. Oh, Brian.
I keep looking at these slides and then it's like, wow, this is a really great slide. Now I want to talk about it. So I really like this diagram. Thanks for drawing it. It occurs to me that one really interesting question that we could ask is, let's look at deployments A and B here first, right? Like you have a network and you put a bunch of Cyan hosts on your network, or you have hosts where you have like a dual stack thing so that you can actually run Cyan applications, versus you have a network and you plop a SIG on your CPE, and that SIG is actually going to be a relatively cheap thing, right? Because it's a Cyan router, and Cyan routers are relatively cheap, right? Like there's not an enormous investment that you have to make, or not a lot of forklifting that you have to do to get deployment B to work. It'd be really interesting to see, like, a lot of the sort of deployment of things in the networking space look a lot more like B than A, right? Like, because deployment A requires you to touch every endpoint, and you have to touch a lot of those endpoints before you get the benefit of what's going on in the endpoint. Whereas you can get a lot of the benefits of this, not all of them, right? Like, so for example, if I'm sort of like doing some sort of TAPS future thing where I have an application that really actually does want to control network access to the path for different sort of like differentiated services for different things, then I really need, since that's running on the endpoint, I really need that on A. What do I get if I just do B, right? Like if I just went and like downloaded sort of like, the Cyan thing onto my Taurus Omnia, and then like now I have Cyan at home, what do I get from that? I think that's not a question to answer right now necessarily, but I think that would be a good thing for that. Like you said a couple of times, it's like, we're not going to get into that because we have some transition mechanisms. I'd said in the interim, sort of both with my individual and my chair hat on, that like an exploration of those transition mechanisms would be super interesting for the IETF community in general, because it's like, hey, you've actually deployed a future internet thing that works with the present internet. Transitions of this case are hard. What are sort of the incremental benefits of doing this? I think this is like sort of a worked example of doing that sort of thing. And like the question that I'd leave with is like, okay, we have this vision of we're going to Cyanify the internet. If you only get to deployments that look like deployment B here, how big of a win is that, right? If you never get the rest of like, if you never have the vision never gets to the point where you have a bunch of Cyan enabled endpoints, where you only really are doing path selection from the gateway, right? Like, so the path selection rules and policies become a thing that's under the local network administrator's control, kind of like in the present internet, as opposed to under the endpoint. Is like, what do you get from there? What is the, if that's as far as it goes, what's the benefit? Because I think there are, I don't know what they are, but I'd really like to see that sort of explored in future work.
Yeah, absolutely. So I think that there were also some discussions last time about documenting deployments and transition mechanisms. To this point, I think two things. One of it is that there is different transition mechanisms with different maturity. So the Cyan2ip Gateway is the one that is used today in production, but there are some research proposals about other transition mechanisms. So for example, I think there is one that is, it will come out at Usenix Security in, well, I'm not sure when it is, but in the next month, describing more of a backbone approach to that. But of course, these other ones are more research. And for the discussion of today, I think I wanted to focus more on what is actually really deployed and productive.
And that is
so
the SIG. That's CP deployed to the customer side, or
that's basically, yes, that would be roughly B. B
Okay.
and as well D. So
Right.
both of them are somehow deployed.
Yeah.
When it comes to
B
getting closer,
B is the most interesting for me from a standardization standpoint, because it also gives you a deployment and operations model that isn't that far from the current deployment and operations model, right? Like you have people who own local networks and you're giving them more, you're giving them more internet. You're giving them new things that they can do that they couldn't do before. It'd be interesting to look at what those are, right? As opposed to, like getting to full native Cyan everywhere. You got to have the browser vendors on board. You got to have the OS vendors on board. You got to have you might need to do NIC. Like that's a much bigger lift. Whereas B is
absolutely
seems much more doable to me.
So this is why the current deployments, they basically follow B or D. And when it comes to benefits, well, of course you get full benefits if there's two Cyan hosts or hosts behind a Cyan gateway that talk to each other. Which is why I think the early adopters are these kind of ecosystem industries like banking, where you have lots of actors that need to talk to each other, and they need to do it with some extra reliability that they do not get over the internet. So when it comes to like the business or let's say benefits of deploying Cyan, these ecosystems like finance or transportation or healthcare, I think there's now a POC being run for adopting Cyan for connecting healthcare institutions. In this kind of market, I think Cyan has a very interesting positioning somehow, or can provide some interesting properties when it comes to the path awareness, security, and so on. So that would be, I think, the first step, the more concrete use case. The other ones would be more, of course, require more change and would perhaps come later on. I hope that somehow answers your question. It was okay.
Juan?
Yeah, sorry to bother again. Just wanted to talk exactly about what Adrian was asking, what Brian was asking. We have to talk about this as well, definitely, as Nico said. But we believe that the scenario at A that will never happen. So clarifying that, meaning that there is so much existing software and so much compatibility that we believe that we will always have this kind of gateways in the middle to allow backwards compatibility for many years, possibly forever, to be honest. But also a mix between A and B would be very welcome. At the beginning, everything is B, and then there are some end hosts that understand Cyan, and their applications can take full advantage of the multipath and multiple properties, like also QoS and so on. Because the SIG, of course, the gateway has limitations. As Brian said, it will only do its job up to the taste of those admins. So whatever flavors they want to use for the paths and so on. So that will not transpire to the end host applications directly. But yeah, we definitely have to talk about this. Yes, thanks.
So no more questions, comments?
Maybe I'll just try to wrap up in just generally asking or commenting like for next steps. I think we definitely got a lot of good input today. So first, thank you all for your comments. They definitely help us to do some more thinking about it, and I think they will also help us iterating, especially on on the component analysis draft, so expect to see an update. And we'll be happy to discuss some of the open points on the list. When it comes to further next steps, yeah, we were wondering if perhaps working on the specification could be interesting. As I mentioned earlier, it would be probably difficult to reach rough consensus right now, and it would be very beneficial for us to at least document what we have today in terms of deployment. So I was wondering if, I'm not sure, the chairs or the audience have an opinion about that. Or if not, yeah, we will wrap up. Oh, I see Brian is around.
Yeah, so actually, I wanted to ask a clarification question on that. When you're talking about documenting the current deployment, this would be the specification of what is currently deployed, or a deployment report. Like, would it be a specification of that of the protocol as it is currently deployed, or would it be a report on the properties of the deployment as it's currently deployed? Does that make sense? Like, which is more useful for you?
I was thinking, so I think there's different things. This could definitely be useful, documenting the deployment, but I was also thinking somehow having the low-level specification of how things work today, just to have it as a starting point for starting to discuss about what, each component. I think so far we got the direction that the control plane PKI and the control plane are the more interesting. So I was thinking more, let's say, in starting to work on some of those components, or starting having a documentation there. But in parallel, we could also, focus on deployments. All
right, no. I just wanted to. I was just asking a clarification question for what it was you were asking for. Yeah, I think that's definitely worth writing down. I would want the research group to take a look at that before we made a decision as to whether we would adopt it as a research group document for publications RFC through this stream. I think we still kind of don't really know how we want to break this work up and bring it into the IRTF and the IETF, right? Because I mean, like, if the goal is standardizing some of these parts of things, then step one is writing it down in an ID, and maybe we have a discussion about that and split those documents up, and some of them go to other working groups or to their own working group, and some of them stay here. I think it's definitely worth starting to write things down, sort of in the ID format, because I mean, like, once it's there, it's not very much work to like shuffle it around, right?
Yeah, that's what I mentioned. I meant, yeah.
Mia Kuhlewend again. So I similarly got potentially confused by the term specification here. So you have this other draft which is describing the whole architecture, but you're talking about writing more drafts, or are you talking about that draft?
So I was talking more about writing other drafts with the protocol, let's say, specification. So just documenting what we have today, how it works.
And you already said it now. You say multiple drafts, right? It's like it's different components that probably go into different documents, right?
I mean, I think we have the 3 core components, and I think it would be a lot of material if we were to have everything together. So yeah, I was thinking about the 3 core components: the control, data plane, and PKI. Yeah, I was basically referring to that. Yeah.
Okay. So specifications, probably.
Yeah, that's why I mentioned. I mean, in the end, it is very important also for us to do thinking. I think for people in the groups to do some further thinking, especially when we want to look at more technical questions. I think then we have to start looking at more in depth, because now we're really looking at, let's say, we had an overview. Now we're looking at the properties, and sooner or later we'll have to get to
So
the lower level bits, and that way we can also then think if we can, I don't know, integrate it with segment routing, or but I think it is important to have this somewhere. So I feel this is probably would be a meaningful next steps. That's why I was proposing that.
Yeah, definitely agreeing. I think the point I want to make is already try to think how you can break this up into smaller pieces, so we can actually take some of these pieces and start working on them in the IETF eventually, rather than putting everything into one big document.
No, yeah, absolutely. Yeah. So it would definitely be at least three documents for the core components, and then there's transition mechanisms. We have a lot of work ahead. But yeah, the idea was to document it first. So I'm not sure if there could be maybe even an informational document being worked on first, and then
So I
having
think
some
you
more.
should just write it down and don't worry about what
Yeah.
we do with it later.
Okay, that's clear. We have some work to do.
So as it turns out, I put myself in queue to agree with everything Miria said before she said it. I think that's the way we need to go. One thing that I noticed in reading the draft and then looking through these slides and then this discussion at this presentation is it really shows the benefits of sort of like your thinking, the Cyan team's thinking of getting into this decomposition, right? Like, so actually sort of digging into it, I think has improved your concepts and gotten us a lot closer to the goal of figuring out what we're going to do in the IRTF and what we're going to do in the IETF. And I'm convinced that as you do the detailed decomposition of these things into these 3 specifications, that you're going to have more benefits to the thinking process of that. I think that things are going to fall out of this and it's going to be like, oh, why didn't, this is obvious. This is the way to go. I don't know what that is yet because I haven't read the drafts yet, but yes, you have a lot of work ahead of you. I commit to reading all of this stuff and helping make it better. And we should probably, after Colin, talk about next steps within the RG, chair hat back on, as to setting up a pace of interim meetings that will make sure that we, keep the energy up on this. Because I'm really excited to see how well it's going. And I think, if we get into a situation where it's like, okay, well, now we're not going to think about this until London, then we're missing an opportunity.
And Brian, I don't know, in the chat, Jeff mentioned that it might be an option, of bringing it to routing people, but having like.
That would be
Yeah.
That would be super. I think I want to get at least the control plane PKI and the control plane documents to the point where they're readable before we do that, because I'd like the routing people to throw arrows at the specifics as opposed to with the concepts. It seems like it would be more beneficial to doc details. So.
Okay, Colin.
Hi, I think Brian and Miria said a lot of what I was going to say already. I think I think it's possibly premature to think about what are the next steps, what's going to be standardized and what isn't. I think the act of writing down the specification here, the act of decomposing it and specifying it will, I think, make it very clear what is ready for standardization, where the open questions, which perhaps this group, perhaps other bits of the IRTF could look at. So similarly, I think someone mentioned the independent stream in the chat. I think that might be a venue for publishing a snapshot of what you have now. But again, the main thing I think is to start writing things down, decomposing it, writing down what you can specify, and then separately writing down what are the things where there are open questions as you specify it. And then over time, I think it will become very clear which bits are research and which bits are standards ready.
Thank you. Yeah, we'll definitely keep writing for the, let's say, short term in the foreseeable future. And I think this will help us move forward.
So I think we can take my last question to the list, but this is more of a holiday schedule question. If we were looking at the last couple of weeks of September for an interim, or maybe the first week of October, is that going to give people enough time to do anything, or do we want to do something that's maybe like, because the London meeting is toward the beginning of November, right?
Yeah, I think it's 11th of November.
7th. So like, I guess we could do something anywhere from the sort of the end of September to the middle of October. And the look on your face suggests to me that you're more interested in toward the middle of October than toward the end of September.
Yes.
Okay.
Yeah, the thing is, yeah, we have to, maybe we can talk offline and see, but from our side,
we'll sort of throw to the list too.
I think me and the other folks that can do like really work on writing, we will be, either busy or out for a while in September. So So yeah, mid-September, late September would be a bit
Okay.
tricky.
Cool. All right, that's good input. I'll start the thread on the list from that. Thank you very much.
Okay, thank you very much.
We do have a
Then
little
thank
bit
you.
more time here. Is there anything else that you want to know from the people in this room today, Nicola? Is there any? I think you got a lot, so no is a perfectly acceptable answer to that
I think
question.
I got a lot. I'm still processing and will be processing in the next few days. So yeah, I will also start writing or preparing towards writing down some of the specifications while iterating on the draft. So I think this will be definitely enough input. And yeah, if we keep the momentum and keep discussing in interim meetings or so on, I think this will bring us a long way forward. So
all right,
I'm very happy.
Cool.
And thank you all for
Thank you very much.
spending so much time on Cyan.
Thank you. Okay, so now let's move to the next presentation about overlay routing problem.
Hello.
Hi, Gang.
Hi, this is Geng, and I'm gonna present this problem statement.
You want to present yourself, or you want me to move? Okay.
No, you can share the screen. Actually, it's not a long slide.
Whatever. Yeah.
Okay, then should I start?
Yeah, please.
Okay. Good day. My name is Geng Li, and I'm from Huawei, and it's my pleasure to present our problem statement of overlay routing and in the internet application. And actually, what we're gonna present is a complementary part to actually what you discussed today. I think we can have good discussion after that. Next, please. Okay, as we can see, actually, internet is entering totally a new generation from before we call mobile internet all the way to the immersive or real-time and interacting internet. And for example, the real-time communication traffic actually have been growing almost 3,000% since the COVID, and maybe it's going to be more right now. And also the VR and AR already have expected a huge annual growth in these decades, and also a very hot term like called metaverse. I think everybody already heard that. I think it's going to be one of the ultimate kind of scenarios in this immersive internet. But in the meantime, actually, this kind of development needs much higher and more strict requirements about networking quality and network transmission in terms of like latency, throughput, packet loss, and jitter, and so on. However, actually, there is a huge technical gap in this internet kind of application scenario with the wide area and the public, we will say cross-domain networks. Because first, actually traditional internet is originally designed to just for connectivity and the best effort delivery. And also the inefficient, I would say very inefficient routing protocol, the BGP, actually is basically the path is computed based on the ISP business relationship instead of performance. Actually, there's no performance guarantee. And actually, it is noted that some path between the locations within Asia actually will be routed through some peering point all the way to America. Therefore, have like extra latency greatly. And also some recent advanced, for example, 5G and SDN, but they are all operating in a single domain. So therefore, you cannot do this kind of end-to-end solution with cross-domain in the cross-domain networks. Next, please. And therefore, actually, recently, I would say an old technology has been revisited, the overlay networking, and it can provide better path selection in the internet. And right now, I think a lot big OTT service providers already deploy this kind of overlay networks with their private infrastructure to provide better performance for dedicate their own service. And in the overlay networking, basically multiple POPs, point of presence, are deployed worldwide to relay the traffic. And also in the network, there can be private circuits or the public or based on purely public internet. For example, Huawei deployed this kind of overlay networking based on a hybrid mode with private circuit and also public internet. And also, for example, Akamai and Agora, they deploy purely on the public internet. And some big OTT, actually, they have their own backbone network, but conceptually, there are also some overlay networking. And basically, in the overlay networks, and endpoints can use overlay forwarding path, and instead of the direct internet path to maybe to achieve like lower latency or bypassing some congestion points. Next page, please. Okay. And actually, the current overlay routing paradigm can be shown as the light figure, and is computed conceptually logically centralized, but actually the whole path can be decomposed into two segments. The first one we call the access, from the source to the access point, or the ingress or the destination to the egress point. And actually, this part, the routing where basically it's like the access point selection process, and the source need to get the address of the access controller and ask the controller going to assign the access point, either ingress or egress, based on some geography, location, or latency. And inside the network, we call the backbone segment. And in this segment, actually, is only maybe composed with like hundreds or like tens of nodes, and basically the controller can configure the optimum path in the backbone, can always find the optimum path from ingress all the way to the egress. However, in this kind of diagram, actually there are three main problems we observe. The first one actually is the local optimal is not always the global optimal. Okay, it's more like our metro or subway system. And even if you find the closest or the best access point, and you find the best path within the backbone, but in the end-to-end perspective, it's not always optimal. And we do have a real example in the figure. For example, if the user from the Zimbabwe wants to send traffic to Thailand, and one way is the black path. Actually, you find the closest ingress point, and which is South Africa and Hong Kong, and you have the good path between them, but the whole latency is around 250 milliseconds. But instead, you don't have to do this. You want to achieve the global optimal, the Zimbabwe can find a further access point, which is actually Dubai, is not shown here, and it's in the middle. And also the Thailand can also access to Dubai, and just one point you can relay the traffic, and the total latency is only 160 milliseconds. But this green path actually is not able to be found in the current diagram, or not mentioning to use that. And the second problem is about complex signaling. Basically, in the current framework, the source need to, if you want to send anything, you first need to have the DNS request to get the address of the destination. And then if you want to use the overlay networking, and you need to get the address of the access controller, and then you ask the access controller to the access point. And so many kind of like complex signaling. And the third problem is basically the motivation of the PNRG. Basically, there's a zero information about the path at the endpoint. There's no path awareness. And if, for example, for different kind of traffic, different kind of service, you cannot have the flexibility to choose the path. Next page, please. Okay, then to address this problem, actually we propose some potential extensions, and actually there are in three places. The first one is about the end-to-end joint path computation. Basically, you can compute the entire overlay path, including both the access segment and also the backbone segment, just to give the entire overlay path. And also, this end-to-end controller can play as a root DNS server. Okay, then therefore to configure the path, you can just use or reuse the DNS tunnel. Basically, whenever the source want to send anything to the destination, for example, the IETF website, and you need the address. Okay, you need to query the DNS, but in the meantime, you can have the overlay path request together with the destination request, and you just need one route, and the DNS, the DNS recursive kind of query, and it can return you the address of the destination together with the entire overlay path. And of course, you need some you may based on the eDNS, the extension of DNS, and maybe you need a kind of new option code for this kind of request. And the third extension actually is whenever you have the DNS response and you already have a settled path. And here the path can include, for example, the list of the POP, and also it can include some path property information, for example, about latency and bandwidth, and you can choose from them and based on the DNS response. And then you can just simply use source routing or segment routing. I think you already talked about this a lot, but actually here the difference is you just directly use segment source routing at the very first point, at the end point, and encapsulate the packet. For example, if you want to use path 1345, you just give the list in the packet header and send to the network. And also, all the POP or the forwarding node doesn't need to maintain the routing state, and it can forward the traffic based on the information in the header and all the way to the destination. And basically that's all. Next page, please. Yeah, this is just some first thoughts, and I think it can be very complementary to the ICI1 work, and we'll be very happy to collaborate with everybody else to try to document this problem state, and let's see how we can proceed. Yeah, that's all. Thank you.
Okay, any comments from anyone? So I am so I suggest you ask for any feedback on the list, right? Because, well, I guess not everyone on the who is reading the mailing list is in this room right now, right? So I do not see anyone rushing to the microphone to give any comments. So I suggest we just start with that.
Okay.
Because I think the first thing we need to find out if there is any interest in the room to work on it, right? So, okay. Sounds
okay,
good?
cool.
Yeah. Thank you.
Thank you, Era.
Okay. And we're going ahead of time. Great. So, Hiroshika, floor is yours. I am. Yeah. Yes. Okay. If you want here, I guess people might hear you better if you do that, but it's up to you.
Keep my face this
Yeah.
direction. So, can I do that?
Yeah, please go ahead.
Okay, so yeah, good afternoon, everyone. I'm Hiroshika Sai from Wide Project and Preferred Networks. I'm going to talk about the separation of data path and data flow sublayers in the transport layer. This was originally intended for the TSB working group, but I think this kind of the discussion should be here because this is related to data path. So next slide, please. So this is the motivation. As you know, the internet is really that is right now, and it was the principle of the internet was the end-to-end, but we have more and more smaller network gears in between the end host. So for example, we have QoS, middlebox, and then we now have the new distributed computing technologies such as the power model machine-to-machine communication and edge computing and in-network computing. In-network computing is a little bit difficult for me still, but we have more middle boxes in the network. So I think the end-to-end principle is now over. So we need to think about how to how to design the future internet. So according to the ROC 1122 and 1123, we have 4 layers: link layer, internet layer, transport layer, and application layers. And yeah, the link layer and the internet layer is okay. So internet layer provides the end-to-end reachability, but the transport layer implements too much. So the next slide, please. So, yep, no problem. Yep. So the IP routing is based on the hop by hop standard nature with a single or multiple queues in the router. But transport layer, some of the functionality of the transport layer are end-to-end functionality. So for example, reliable data communication, retransmission, integrity check are the end-to-end functionality. So the routers do not need to do nothing. So data path is just a data path. But of course, in addition to the reliable data communication, flow control for the receive buffer management is performed by the end host. And the transport layer security is also performed on the end host. However, we have some path-dependent functionality. So the end host needs to know about the data path. So for example, when we perform the path MTU discovery, we need information of the MTU on the data path. That is accomplished with the ICMP now, but we sometimes we have many problems with the path MTU discovery. And congestion control is also performed on the end host. However, the congestion is actually occurred on the routers or data paths in between the routers. So, and the ECN, explicit congestion notification, is implemented in the router to notify the congestion information to the end host. So some of the functionalities on the transport layer require the information of data path. Moreover, the several middle boxes requires to know the waypoint, and this kind of middle boxes may have a states of the data flow. So we need to implement some kind of the waypoint aware routing technologies. For example, the firewalls are implemented at the gateway, or the transparent proxy could be implemented with the, deployed with the policy-based routing. So the transport layer needs to be aware of the data path for some functionalities. So next slide, please. So, and more, we have more path-aware data communication here. So multi-path, we have multi-path protocols. We have SCTP, MPTCP, MPQuick, MPDCCP, and so on. So that these protocols should be path-aware so that we can use the two or more data paths efficiently. And the AQM is aware of data paths. Actually, it's aware of the queue of the data paths. And in addition to this, we have more emerging technologies such as the PubSub M2M communication, edge computing, network slicing, and in-network computing. So this is achieved, these new technologies are achieved with the network programmability. So the infrastructure of the IP routing becomes more smarter, I mean. So next slide, please. So this slide shows the problems with the current transport layer protocols. So the current transport protocols are tightly coupled design. So all components of the transport layer functionality are integrated to the one protocols. So for example, Quick, that is a very good protocol, but that has many functions in the one protocol. So if we want to make a MP Quick standardized, we need some kind of the reinvention for the Quick. Although we have a MPTCP or SCTP for the multipath protocol. So it is very difficult to develop the new transport layer protocols. So Quick is okay, I think, because that is just a transport layer. But if we need some help or cooperation from the IP layer, for example, if we have ECN for the congestion control, that would be better. But if we want to design such kind of feature that cooperate with the IP layer and the transport layer, I think we need to abstract the current transport layer in order to develop the both IP-friendly and transport layer-friendly network extensions. So next slide, please. Thank you. So I have just reviewed the transport layer functionality here. So I think we can separate the transport layer functionality into two sublayers, two functionality. One is data path and the other is data flow. So regarding the data path, that is the stateless or purpose state that handles the purpose states, or that is a stateless. For the data flow, that is handling the path flow states. So for the data path layer, we have functions such as the trajectory or waypoint handling, bidirectional connection, resource monitoring for congestion control, and the congestion control, data flow multiplexing. This is similar to the Quick's connection. So the Quick connection can multiplex the multiple flows over multiple streams on the one connection. So this is similar to the Quick idea. And data path function, one of the data path function is the packet duplication. So I think there was another research group or working group where was talking about the fake on the TCP protocol. So I think that this kind of the duplication or replication could be a data path functionality. On the other hand, as for the regarding the data flow the sublayer, the retransmission or flow control, that is for buffer management for the receive side, and for flow prioritization, end-to-end security, and inverse multiplexing for multipath protocol could be a data flow functionality. So I separate this functionality into two. So next slide, please. So this is my proposal. So for the future development of the transport layer protocols and as well as the IP layer extension to the IP. So this is what I said in the previous slide. So I don't think I need to mention more. But this kind of the layering. So the data path layer is above, beyond the IP layer, and the data flow layer is above the data path layer. So the data path layer protocol can multiplex the multiple data flows over the connected. That could be a bidirectional connection or a unidirectional one. So the data flows are multiplexed over the data path. This means that. So next slide, please. So this is one of the use cases. I'm thinking about the many use cases now, and I'm reviewing the other transport layer protocols, TCP, Quick, SCTP, and so on. But this is I have only, I thought I had only 10 minutes, so I picked up one use case here. So recently, we have lots of machine-to-machine communication devices in IoT. So if you're downloading something human downloads something, you are aware of some kind of the network. So the best effort is working fine. But for the machines don't think. Machines don't think. So they are trying to send packets, send a file as much as possible at the maximum rate. So if we use the best effort model, that may cause some troubles in the scalability problems. So if we can have some help from the network side, so if we can know the congestion information or some kind of priority information feedback from the network side, we can coordinate, arbitrate the flow priority. So if we have two priority data here, high priority one, the low priority one. Low priority one is just for archive, and the high priority one is for the data processing. If we have the data transfer for the archive, and if the high priority data is studied after the data transfer of the low priority data, and then this data path may have a congestion. So if we have the feedback from the router from the data path layer, this low priority data transmission could be controlled. I mean, arbitrate and get a more slower data rate, so that we can have a higher rate for the higher priority data. So this is very similar to the ECN. So for this use case, so next slide, please. So this is the kind of pseudo flow diagram. So I don't need to say anything more, but this scenario could be achieved with the TCP, ECN, and DSCP. But if we can have more sophisticated or more extended information from the data path, we could have a better congestion control algorithm or such kind of things. So recently we the some of our data center transport layer protocol implement the streaming telemetry to get the more precise information on the buffer on the data path. So if we're going to use such kind of information, I think the separation of the data flow and the data path is useful. So next slide, please. So this is the last slide from me. So thank you for giving a time here. I think this is very related to the PANRG here. This is related to the data path. So I want to get the feedback from you, and I'm going to continue the discussion on the gap between the hop by hop and the end-to-end mechanism between the IP layer and the transport layer from the viewpoint of data path and data flow. And I'm working on reviewing the existing transport layer protocol functionality. And so the third item is what we want to ask you here. So I want to, as the internet is kind of dirty, right? So, but I don't want to create a clean slate architecture because the internet is a great architecture, but we need to fix or modify some of that. So I want to discuss the architecture for new communication model and distributed computing here. So if you have any use cases that could be helpful with the separation of the data path and data flow sublayers, I want to know that kind of use cases. So that is I want to do. And as a protocol development, I think I need to review the existing transport layer protocol, but I want to develop some kind of example data path and data flow protocol using this architecture. So that is my next steps, and I want to get the feedback on the architecture for future data communication for better world. So thank you. So thank you very much.
Okay, thank you. I think we have Gori in the queue.
Yeah, I'd just like to say thank you for the clarity in your talk. That was really clear. What are your plans for the next year? Are you going to work on this more?
Yeah, I intended to work on this item in the TSB working group so that we can publish the new layering model. But before doing that, I think it is better to discuss the existing protocol and future potential models or potential use cases, because this is the not for the past. I mean, this is informational, but this will be for future. So I wanna work on the historical review and the future discussion here.
I would love to see more of this discussed in this research group. It was really good. Thank you for your talk.
Thank
Okay,
you.
Brian.
I am putting myself in the queue as an individual. Seconded Gory. This is a discussion that we've had at various levels of clarity in the IETF for a long time, right? Like, so trying to figure out kind of how to take these transport layer functionalities and make it work in a cooperative way in the network that we have. And I really like the this framing of this is a really interesting way to take it. So thank you very much for the presentation. I think one question I would ask is, so like speaking as a proponent of the long dead plus BOF, which was a previous attempt at having this discussion, I think about 5-6 years ago. I'd ask if you have seen the RFCs that came out of the IAB Stack Evolution program on path cooperation and wire images. I can follow up with you offline about that. There's like a couple of things that I think might actually help you with the framing of the historical discussion. As an individual, so no chair hat on, I also think that sort of we've done a good service to the community as this research group when we've looked at sort of like the history of interaction between the transport protocol and or the transport layer and the rest of the network. So Spencer's draft, this work looks like it's very much in the same lines as that. So I would love to see this discussion continue in PANRG as well. So thank you again.
Yeah, thank you. So I think this work is also related to the this morning discussion in the EDM. Yeah, that is a.
Yep.
I'm not sure what that's what stands for, but
electronic dance music.
Yeah. So I think that is also related, right?
Yes.
Evolutionarity and the main something.
Evolution, deployability, and maintainability. Yes.
Yeah.
But the joke is electronic dance music. So.
Yep. Thank you.
Yep. Thanks.
So I'm going to continue this work. So I want to send an email after this session. So please give your feedback from this research group so that I can work on the this work more harder. And I want to discuss these kind of things among the this research group and among the IETF community, I think. So please give your feedback. I want that.
We still have a little bit of time. Does anyone else in the room or in MediaCo want to come up and give some feedback? Not on the list. Going once, going twice. Cool. We'll take it to the list. Thanks again.
Thank you very much. Thank you.
Okay. Thank you, everyone. Thanks, Suresh, for taking notes. Appreciate it. Okay, so it looks like we have some action items and some reading to do. So see you in London, or actually on the Cyan interim sometime in October. And we can get like 11 minutes back.